All right, let's just rip the Band-Aid off. I'm going to start with a statement that for anyone who builds on the web might sound a little crazy. The content delivery network, the fundamental tech that's been the backbone of the internet for over 20 years, it's dead.
Yeah, I know. It's a bold claim, but honestly, the name itself, Content Delivery Network, is an anachronism. It's a word that's just stuck in the 90s. It describes a solution for an old problem, and it completely misses the massive architectural shift that is happening as we speak.
So, this means we've got to stop thinking in terms of just delivery. The infrastructure we used to call the CDN has evolved into something way more powerful, way more intelligent, and frankly, a whole lot more interesting.
And that's the real question here, isn't it? How did the hero technology that literally saved the early internet from collapsing under its own weight suddenly become obsolete? Well, to get that, we have to go back, way back.
Okay, picture this. It's the mid-90s. The internet is exploding. But this crazy growth had this awful side effect. An experience so common and so painful, it earned its own nickname, the World Wide Wait.
The growth was just staggering. We went from about 50 websites in 1992 to over 10,000 just 2 years later. And by 95, web traffic wasn't a blip anymore. It was almost half of everything happening on the internet. The problem? The internet was never designed for that. It was all built on this super simple idea, one central server for every single website. To really feel what that was like, look at this number. That's how long it did take to download a single 3.5 megabyte photo on a 56K modem. That's one picture from your phone today. This wasn't just annoying, it was a brick wall standing in the way of the web's future.
And it wasn't just about things being slow for you. The whole system was fragile. A popular news story, a big software download, it would create what they called a flash crowd. So many people would try to access the server at the same time that it would just give up. It would crash, taking the site down for everyone. The web was becoming a victim of its own success.
The crisis got so bad that in 1995, the inventor of the web himself, Tim Berners-Lee, threw down a challenge to his colleagues at MIT. He basically said, we need to find a fundamentally new and better way to deliver content on the internet. He turned a worldwide frustration into a high-stakes math problem. And the team that cracked it was, well, it was like something out of a movie. You had the professor, Dr. Tom Leighton, one of the world's top experts in applied mathematics. And then you had the prodigy, his grad student, Danny Lewin, a brilliant mathematician, a former elite special forces officer, and just a relentless problem solver. The breakthrough came from Danny Lewin's master's thesis. It was an algorithm called consistent hashing, and it was pure genius. It brilliantly solved the biggest problem. How do you add or remove servers from a huge, constantly changing network without having to reshuffle all the data every single time? This mathematical magic trick became the foundation for the entire CDN industry, and a little company you might have heard of called Akamai. And this wasn't just some theory on a whiteboard. In the real world, this invention created the global performance backbone that we've all been relying on for decades. It basically went to war with the internet's two biggest enemies, distance and delay. And it won. So how does it actually work? Well, it's actually beautifully simple. When you request something, a smart DNS system grabs that request. Instead of sending you halfway across the world to the website's main server, it directs you to the closest server to you. That's a point of presence or a POP. If that local server has a copy of what you want, boom, a cache it. You get it instantly. If it doesn't, no problem. It just goes and gets it from the main server, saves a copy for the next person, and then sends it to you. And the impact? Oh, it was absolutely revolutionary. For Netflix, it meant building their own CDN to push over 100 terabits per second. For an e-commerce site like Zalora, it meant a 46% boost in response time and slashing costs by nearly half. And for a game like Fortnite, it cut load times by 50% and latency by 60%, which, as you know, is everything in gaming. The CDN wasn't just nice to have, it was essential. But, and there's always a but, this is where our story takes a turn. The very model that saved the internet started to create a whole new class of problems. And these are problems that the traditional CDN architecture just wasn't built to solve. The hero of the 90s has finally hit its breaking point. So what went wrong? Well, the old CDN model really has three critical flaws. First, businesses got totally stuck with vendor lock-in. Proprietary APIs made it super expensive and risky to ever switch.
Second, trying to fix that with a multi-CDN strategy just created an operational nightmare. But the third flaw, the third one, is the real killer.
The way people attack websites has completely changed. See, the old war was all about volume, just throwing a tidal wave of traffic at a network to knock it over. CDNs were great at soaking that up. But the new war? It's about sophistication. Attackers now use these sneaky low and slow attacks that don't use much bandwidth, but are surgically designed to drain a server's memory or CPU. A CDN that's only built to deliver content is completely blind to this new kind of threat.
And this breaking point is forcing a huge paradigm shift, removing away from the content delivery network to something totally new, the Edge application platform. Now, this isn't just an upgrade. It's a complete reimagining of what the edge of the network is even for.
We need a new metaphor to even think about this. The old CDN was basically a fleet of delivery trucks. It was a logistics tool for moving static boxes from a warehouse to your door. The new metaphor? A neural network. It's not about passively moving things around anymore. It's an active, intelligent, interconnected web where real computation happens everywhere, at once. So what exactly is an edge application platform? You can think of it as a fusion of three things into one seamless layer. Super fast content delivery, yes, but also intelligent security and critically programmable compute. It transforms the edge from just a distributed hard drive into a distributed supercomputer. This massive shift is being fueled by a perfect storm of three key technologies. First, we finally have the ability to actually execute code right at the edge. Second, serverless platforms like Cloudflare Workers are making it easy for any developer to program the edge. And third, we're layering in AI and machine learning to constantly optimize the network and even offer it up as a service. And this gives us a really clear roadmap for the future. Right now, we're in phase 1, building that programmable foundation. What's next is phase 2, infusing the edge with AI that developers can just tap into. And the long-term vision, phase 3, is a fully autonomous edge, a self-healing, self-optimizing, intelligent fabric woven directly into the internet itself. This all boils down to one simple but incredibly powerful idea. The network edge is no longer just a delivery boy for an application running on some distant cloud server. The network edge is becoming the application. All the logic, the data, the intelligence, it's all moving from that centralized cloud out to the edge, just milliseconds away from the user. And this leaves us with a final massive question to think about. As this new architecture takes over, the lines between who's a network provider, who's a cloud provider, and who's an application platform, they're all going to blur into nothing. And that raises a fundamental question about who is going to control this powerful new layer of the internet and what that's going to mean for the future of how we build absolutely everything.